So welcome again. Today we take a look at the physics of the atom. Right? We'll do a quick summary on the physics of the atom, and we'll try to do a few questions on this topic from CSEC past papers. So when we take a look at the physics of the atom, we start on the nuclear model. There were many models before this, but we focus our attention more on this model. This model, which is what we are familiar with now, as we model, this model here, is the model that came about as a result of Geiger and Marsden gold foil experiment. What they did is they took gold foil and they shot the gold foil with alpha particles. So alpha particles, they were incident on a thin sheet of gold foil, and there were three main observations that they came up with. The observations were that these particles mainly pass straight through. Most of them went straight through. So that basically said that, you know what, these atoms that make up the gold foil are made mainly of empty space. They also observed that a few of these particles were deflected, right? Alpha particles, what are alpha particles? Alpha particles are really helium atoms with a charge of +2. So they observed that these atoms, the ones that didn't go straight through, were slightly deflected. What did that mean? Well, that simply means that this central core that the atom appears to have must be positively charged, because positive and positive causes a deflection. So it must have some sort of positive charge in that core. They also observed one more thing. They also observed that the alpha particles, one or two of them, a very small amount, were reflected. It means that it hit something and it came right back at the incident particles. What they concluded there was that the atom had a central core, and it was a solid core. So basically, Geiger and Marsden, together with Rutherford, they came up with this nuclear model of the atom. And the nuclear model of the atom is mainly made up of empty space. It has a central core that's positive. Later work by guys like Chadwick and so on, they came up with the electrons and all these different particles. So the nuclear model is the model that we will focus mainly on. And in the nuclear model, there's a nucleus and there's a shell. In the nucleus, there are protons and neutrons. In the shell, there are electrons. There are protons and neutrons and electrons. These are the three subparticles inside the atom. And the protons have a positive charge. Electrons have a negative charge. Neutrons have no charge. Protons have a mass of, let's say, 1. Neutrons mass 1. And electrons have a negligible mass. We will consider it to be 0 for now. So these three particles are the main particles that we're going to look at. And these particles, protons and neutrons, are called nucleons. And these numbers, E and Z, these letters represent something when we look at the periodic table. In the periodic table, for example, you will see elements. You will see elements, for example, 12C6. C represents the symbol. The symbol is for carbon. 12 represents the nucleon number, and X represents the atomic number. 12 nucleon, 6 atomic. Right? These two numbers for a neutral atom represents protons, neutrons, and electrons. We can work out these things. So, what does Z represent? Z represents the proton number. What does N represent? N represents the neutron number. And, well, E represents the electron number. How do we work out these things? Very simple. For this 12,6 carbon atom, we will see that N is the number of neutrons and n is simply 12 minus 6. 12, or E as it's called, is the nucleon number. So it's 12 minus 6 gives us the number of neutrons. C is the atomic number, which is 6, and proton number. So the number of protons is 6, and the number of electrons is equal to the number of protons if the atom is neutral. So it's also 6. Okay? So what does neutron mean? Neutral simply means that the number of electrons and protons is the same. Okay? And that's basically what you need to know for the nuclear model. Right? So Geiger mass then, gold foil, half a particle shot at it, 3 observations. Most went straight through, some were deflected, and a few were reflected. What was the conclusion? Well, the atom is made up of empty space. It has a solid positive core. And that's basically the conclusions of the Geiger mass experiment. And these are some simple things about the atom. Okay?